Welcome back, guys. This is the exercise problem 6.22, and the statement of this question is, if a set of observations is normally distributed, what percent of these differ from the mean by part A of it is more than 1.3 times sigma, or 1.3 times the standard deviation, B less than 0.52 times sigma, or 0.52 times the standard deviation. Okay, so let us first solve part A of my question. So the solution, okay, and in solving part A of my question, the information is at the 1.3 times sigma from the mean. So if this is the normal distribution, and we can see here that this is mean, and let's say this is what, this is 1.3 times sigma, and this is minus 1.3 times sigma as well. Okay, you can see that both of them are 1.3 sigma away from the mean. Okay, this is 1.3 sigma times away from it, and this is also 1.3 times sigma away from it. So therefore we have to consider both of them here. Okay, both of these sides will be included, because in finding out the distance both of them are included. Okay, so what is this distance equal to? If this is mean, so this point will be at mu plus 1.3 sigma. Okay, and this point will be at mu minus 1.3 sigma away from it. Okay, so you know that these are the 2 points. Now in order to find the probabilities of them, it can either be this one, or countering both of them, because the information or the percentage we want to find out here is this one and this one. These are the areas or the percentage areas we want to find the percentages of which. Okay, so in order to calculate it here, it would be the probability that x is greater than mu plus 1.3 times sigma, plus the probability that x is, this is the less than mu minus 1.3 times sigma. Okay, so these are the equations. Now in order to proceed further here, we remember that exactly previously x was equal to what? When we wanted to convert any information from z to x, what we used to do, it was basically mu plus z into sigma, and this was basically from what? This was from z equal to x minus mu divided by sigma. Okay, from it we got this one. Now here you can see that these are the similar formulations. You can also see here that this is the similar formulation, and here we can see that the value of this z is here and the value of another z is here. So let me call it z1 and let me call it z2. So therefore it would be the probability that x is greater than 1.3 or z1 plus the probability that x is less than minus 1.3. Okay, these are basically the probabilities. Now similarly here you can see that this information is similar as this information is, because this normal distribution is symmetrical with respect to this mean. So therefore both of these percentages are the similar. So therefore now only considering this one, because this basically corresponds with the less than sign, so adding both of them, it will become what? Let me call this one and these, as these two are equivalent, so therefore this is equivalent to minus 1.3 as well, and this is the original x is less than minus 1.3. so therefore it would be the 2 multiplied by the probability that x is less than minus 1.3. okay, now this is what? This is in z distribution, and in order to find out this probability, what we can do, this is the similar formulation, and in order to find it out, we can move to the z distribution table where we had to find out the probability that x is less than minus 1.3. So let us move there. So x less than minus 1.3, here it is. Okay, so this is the value, this is here minus 1.3, so it is 0 0.0968, 0.0968. okay, and multiplying it with 2, 0.0968 multiplied by 2, it would be what? It would be 0.1936, 0.1936, or it is what? Let me solve it here. It is 19.36%. okay, so the area which is more than this value is 19.36% of the overall normal distribution. Okay, so that is what, that is basically the solution of part A of my question. Now let us move to part B, and here that value is less than 0.52 sigma. okay, so let me solve it, and here this is the normal distribution. okay, so 0.52, let me have here 0.52, and this is minus 0.52 because of the similar reason which I explained here, and these are the two values, and in finding it out, this is basically the area, because now here the probability that x is less than 0.52 sigma. okay, this is the area, and after solving it like this one, we will get that this would be the value of z1, so here it will be the z1, and also here the probability that x is greater than minus 52. okay, combining them both, we can also write it like probability that x is greater than minus 0.52 and less than 0.52. okay, so in order to find out this probability, so it would be the probability that x is less than 0.52 minus the probability that x is less than minus 0.52. okay, so let me find them out by the z distribution table, and this would be, let me write it here as well, that is 0.52 minus the probability that x is less than minus 0.52. okay, so first let me find it out. So x is less than 0.52, so this is 0.5. okay, this is 0.5 and this is 0.52, so 0.6984, 0.6984. okay, and minus x is less than minus 0.52, so minus 0.52 is minus 0.5 is here, and this is minus 0.52. let me see. No, this is incorrect because this one is the 0.5. okay, this is incorrect. 0.30153, 0.30153. okay, so let me solve it here. So it would be 0.6984 minus 0.30153, so this is 0.39687, 0.39687, which is equivalent to 39.7%. okay, and this is what, this is the solution of part B of my question. okay, so you have seen that how we have solved it and what are the intentions behind these type of questions. If you have any question, you can ask me in the comment box. See you soon.